Hello, I'm Michael Hinshaw, CEO of Green Circuits. Welcome. Today we're going to give you a tour of our facilities, led by our Chief Operating Officer, Mark Evans.
Hi, I'm Mark Evans. I'm the COO here at Green Circuits, which is a fancy name for the operations guy. And welcome to our manufacturing department. We've got 60,000 square foot here in San Jose, California, the first half of which is dedicated to our 5 surface mount lines. We'll begin here in SMT line 3, which is right behind me, and we'll go through in detail. So the first and probably most important process step in the manufacturing of a PCBA starts right here with screen printing. This is where we overlay a metal film on top of a bare PCBA and squeeze solder paste through apertures. The board ejects, and what we're left with is sometimes tens of thousands of tiny little sandcastle-like deposits of solder paste. That's what the first step of the process does. As I mentioned, the first step is solder paste printing, and I mentioned it is one of the most critical process steps we have. As a result, we have a 3D solder paste inspection machine straight after the solder paste printer. It's gonna look in 3 dimensions at every single paste deposit that's placed down. There's tens of thousands of these deposits that are made, and we want to make sure that every deposit is perfect. If you can imagine when you're building a sandcastle on a beach, if the sand is too dry, it can stick to the sides of the bucket. If it's too wet, it can slump. Exact same thing can happen in solder paste printing. So we don't rely on people to inspect this. It's a high-tech device that looks in 3 dimensions to make sure the whole volume of the paste deposit is there. So screen printing is done, solder paste is on the bare fab. Now it's time to place the individual components on top of the solder paste ready for soldering. And we use Juki pick and place machines. They're extremely flexible and they're extremely reliable. This is why we use them. The beauty of the Juki platform is in our environment where we typically change over 3 times per shift. So we need that changeover to be quick. So the trolleys here give us that ability. When it comes to changing over from one product to another, you quickly change the program type, unhook this trolley, wheel it out, wheel another trolley in, and you're basically ready to go. So the changeover is done. That's the beauty of the Juki pick and place machine. From this point, we've put solder paste on the bare fab. We've placed all the individual components on top of the solder paste. Now it's time to actually make the solder joint. So the solder joint is made in this rather long oven. The boards enter the oven. They're in the oven for around 5 to 6 minutes. That's how long it takes to create the solder joint. We use identical ovens on all 5 lines. The Hella 1810s, they have 10 heat zones and 1 cooling zone. And the reflow takes place in a nitrogen atmosphere. We generate nitrogen internally from our own nitrogen generators. So as the board slowly moves through the reflow process, the flux, which is part of the solder paste, is activating. For the first sort of 2/3 of the journey, that's what's happening, and the heat is gradually getting up. Then for about 45 seconds, right towards the end of the oven, that's where reflow occurs. So that solder paste that had a tacky paste consistency turns molten. So it goes from a toothpaste kind of consistency to a mercury kind of consistency. And then right at the end, just before the board exits, which is critical, is a cooling zone, which turns it from molten solder to a hard solder joint. And that's basically what we're making here. So the board has exited the oven, so all the solder joints are made. First thing that happens to it is it gets QC, quality control, inspected. Julie here is looking at Julie's going to do a first article. She's going to check that general solder quality. She's also going to look at, she's got access to customer assembly drawings, bill of materials, ECOs, deviations, any quality alerts from previous builds. We're not expecting Julie here, the quality control, to catch everything. That's automated and it's further down the line. This is more of a general quality inspection. Okay, so we finished the QC inspection. Now it's time for AOI, automated optical inspection. It's a couple of high definition cameras that are looking at the board again in three dimensions. When you bear in mind that the boards we build range from flex boards that are postage stamp size to 58 layer, 17,000 placement boards, we're asking a lot of a human inspector to ensure that everything is right. So we really rely on high-tech equipment like an AOI to make sure that all the components are in the right place, they're the right value, no misalignment, no wrong orientation, and it actually can also inspect some of the visible solder joints as well. That's what Chris is doing right here. So next level of inspection is the X-ray machine. X-ray is required to inspect solder joints that are not visible to the human eye or visible to automatic optical inspection. Michael here is taking a closer look at an assembly. We typically look at BGAs, QFNs, anything with a hidden joint. We look at barrel fill on through-hole components, and we're looking for uniformity and size of the joints, as well as make sure that acceptable levels of voiding, which can be caused by outgassing during the reflow process. So SMT assembly process is now complete. In some cases, we need to wash the boards. And in most instances, a water-soluble wash is fine, which is the second section of this machine here. It's deionized water, heated under pressure. If required, we also have a chemical wash inline. It's very rarely needed, but it's there just in case. So we finished the SMT process. Now we come down to assembling through-hole components. If the through-hole volume is small, we've got a dozen very highly skilled hand soldering folks that have dozens of years of experience in what they do. So if it's a small amount of components that need soldering, we leave it to the experts. So if we have lots of through-hole components on a PCBA, or a board that has components that sink a lot of heat, we have to use one of our three selective wave solder machines. These machines have a molten solder nozzle that moves around each component pin, soldering the board, soldering the component pin individually. It has a large preheater to make sure that any heat sinking components get sufficient heat to make sure that the solder wicks up through the hole properly. So now we're at a point where we can perform electrical tests. These are our three flying probe machines. They're all Takaya, two single-sided machines, the one you can see behind me, and this guy, which is all of 2 weeks new, a double-sided machine. It's much faster than the single-sided. I don't need to handle the board twice. And the measurement head, the measurement card is on the head, so there's no loss through cables into a card cage. And of course, it says double-sided. There's 4 probes on the bottom, 6 probes on the top, and that makes for better test coverage if you have a test net where one end of the net is on the top side, one end of the net is on the bottom side. You can still test that net. So this is the very end of the PCBA process, and this is final QC, where our quality control inspectors are taking a final look at the boards before they get packed and shipped. They check in for general quality, They're looking at customer drawings, customer BOMs, looking at deviations and ECOs to make sure everything is the correct revision and the latest rev or deviations, if any, were in place. It's our final quality inspection before the boards get packaged and shipped out to the customer. So here we are at one of our box build cells. This is where we don't just make the PCBA, but we actually make the final product that ships to the end customer. And the beauty of this particular cell is that it was designed and each individual workstation was custom built by the operators that operate the cell. So they were given a challenge and on how to redesign how we build these assemblies, and they came up with the solution themselves. They were helped by our lean engineer, but they have a real sense of ownership because they were involved in the whole process from start to finish, which is perfect, and they're committed to make it work then. So the cell itself is a very simple U shape. It starts right here with some sub-assembly, and then as we pan around the U, we have cable assembly being inserted, PCBAs being inserted, then some functional level testing, and some final assembly before it goes into the very end station, which is the final packaging box. And it's really as simple as that.
Thank you for joining us today for our virtual tour. Please reach out to us if you'd like more information.